Okay, so first up, yesterday, or last time we met actually in this case, you learned that assume for a moment it's a 30-degree angle. I know it's a little big for 30, but it's a little small for 45. We'll say it's a 30. Could also be written there. It's just showing kind of where the spot is that leads to that angle being 30. But we kind of label it on the outside there. And then we gave it a pi over 6 name. And that's in what? Cows, chickens? Radians. Very good. Okay, so that's pi over 6. How about this spot? Some people would say it's 3 pi over 6. Other people would say it's pi over 2. It's the same thing. It's just counting by sixths instead of halves. Okay, so then where is 7 pi over 6? Would you please label it on a circle like this? 7 pi over 6. Well, 6 pi over 6 is right here, but that's not what he asked. What Mr. Server asked for was 7 pi over 6, and that would be right there. Raise your hand if you knew where 7 pi over 6 was. Awesome. You're learning the basics of radians. Okay, a 2-second review is that if you had a radian, 1 radian, exactly 1 radian, then you'd have this spot where this is equal to that, which is equal to that curve, where all 3 are the same. Then that angle's a what? It's about 60 degrees, and it's called a what? A radian. 59 is better to say, too, because then you'll remember that you can't have exactly 3 of them. If they were 60, it would end up right here, and it would be 3 radians there, but it's actually 3.14 radians, hence the whole pi thing, and 180. And pi and 180 go together such that if you are given something like 2 pi over 3, and you're just stumped on where that is and how many degrees it is, you could multiply by something. Don't say it, do it. Multiply it by something. I know many of you just have it memorized, and you can be like, oh, I know that one, because I know pi over 3, and this is twice that much. I want you to remember that this is multiplying by pi over 180, or 180 over pi. He's got it. He's doing it right so far. She's doing it right so far. Are you doing it right so far? Tell me what you're multiplying by. 180 over pi. You said it kind of quiet, like you weren't sure of yourself, but how are you sure of yourself now? So that what will happen? So you can cross the pi's out. Very good. Okay. And then you just have to simplify that. I personally like to make this, if you can factor it, you should. 3 times 60 is 180, right? And then why'd I do that? So that the 3 can cancel the other 3. 2 times 60 makes 120. Raise your hand if you had 120. Awesome. So that's where 2 pi over 3 is. It's about here. And I could call it 120, or I could call it 2 pi over 3, or I could call it 480. What just happened there? I went all the way around to here, and then a whole nother 360, and I still ended at the same spot. That's it. Yes. So you can get there by going past it, keep going, and then hit it again. All right, if you understood that, that's called coterminal, because they terminate in the same place. Right there, back to our 30-degree angle. I'm going to call it 30. I'm going to call it pi over 6, because I know you know those two. Can you tell me 2 other ways to get there? Hint, what I'm talking about is that's always your starting spot. And then this line can either get there this way, or it could get there this way, or you could use radians to go this way, or you could use radians to go that way. Do you remember how if you go backwards, it's negative? Okay. And then the last thing is, I just showed you, you could start here, go here, but then keep going past it another whole time and then stop there. Those are all coterminal. They terminate in the same place. Cohabitate means live in the same habitation. Okay? Coterminal means terminate at the same spot. All right, would you please find for me, I just gave you hints at all of them, 3 other ways to say this angle. One of them is negative, some negative big number. This one's negative, but in radians. And one goes past it, comes all the way around, does a full circle, and then stops at the same spot. Find those 3 other ways to say this. This is a typical R2 question. Obviously, it's not that tough. If you've already got it mastered at this point, it's pretty easy. All right, I'm going to pause for a second. Let me give that a try. Okay, so I hope you figured out that it was negative 300 and something. What was it? Negative 330. Good. If you think about it this way, it was negative 360, but not quite that far. Back off 30 degrees, you got negative 330. That's just a way to think of it. Okay, another answer that was right was negative a whole bunch of pi over 6's. How many? Well, negative 6 pi over 6 would have got me to here. And then you just keep going, and it ends up being negative 11 pi over 6. Raise your hand if you had that one right. Very nice. And then the last one is a big angle that's way bigger than 30. Did you get 300 and something? But not 360. What is it? 390. That would have been go 30, but then keep going. And a whole nother circle, which means 360 more, 390. Okay, there. That's called coterminal. That it for today? I wish. No, we have a bunch more stuff I got to teach you. The main thing is called dimensional analysis, and you've probably seen it in science before. If you didn't see dimensional analysis, did you ever see, what's that other thing that's like it? Stoichiometry? Yeah. All right, so how many of you learned it with stoichiometry? Like, that's a word you've heard before. Okay, how many of you learned it with dimensional analysis? Which one's which? Like, is one in physics and one's in chemistry, or what? Stoichiometry is chemistry. Dimensional analysis is physics. All right. To be honest, this is more dimensional analysis than it is stoichiometry, but here's how it goes. Imagine for a moment I had a bike wheel in here with a piece of gum stuck right there. Can you picture that? Let's say I just flip my bike upside down so that I can spin the wheel freely, and there's a piece of gum on there. And if I spin it, the piece of gum will go around fairly fast. Okay. Let's say I really spin it as fast as I can. I pedal the pedals with the bike upside down, and I get the thing really clipping along, and it's going 60 rotations per minute, 60 RPM. And how fast the gum's going? Well, it depends. What does that depend on? What's the one thing you don't know that you need to know? The radius. Very good. What is a typical bike radius? Does anybody know? 27 inch, that's pretty common, but that's icky because it doesn't divide nicely. Okay, I'm going to go with 28 just because, believe me, you want half of it, so let's use 28. All right. Okay, fine. You hardcore bikers can argue about this later. 28 is what we're using. So, will you please figure out how fast was the gum going? Now, I know if you've done this before, you probably totally know how to start, but there's a lot of kids in here who either haven't had it or haven't had it for a long time. So I'm going to help them get started. 60 rotations per 1 minute. That really helps so you can see your units. Then we're just going to multiply by a whole bunch of fractions. And the rotations, you might be saying, well, I wasn't going to do rotations. I was going to do a circumference. Well, that's where you can swap out and say 1 rotation. Get how that'll cancel the other rotation? 1 rotation is equal to 1 circumference. And what's a circumference in this case? Do you remember the formula for circumference? I would say only half the kids in here even know it. I'm challenging you with this. Oh, dang it, a bunch of people just said it. Pi times diameter. I bet you a lot of people wouldn't have had that one on their radar, and that's one that gets people on the ACT also. It's circumference. Like, oh, dang it, I don't remember that one. Circumference is pi times diameter. So I'm putting that here. Why? Because the pi times the 28 in inches is equal to a rotation. This has to be equal to that. This 60 rotations happened in 1 minute. They went together. Every fraction we multiply by goes together. Like, for instance, next we're going to do 12 inches. with, what do you think? 1 foot. Why did I do that? Because I wanted the inches to cancel. So now rotations have canceled, inches have canceled, and I have feet per minute. What did I ask you for? Miles per hour. I want how many miles per hour that gum is going. I spin it around 60 rotations per second. How fast is the gum going? Yes, you remember me saying that? I did say it, and I'll say it one more time. You will be expected to know the number of feet in a mile, and we won't give it to you. You have to know it, so memorize it. I'll give it to you one more time, but you need to memorize it. Otherwise, you'll have to look it up between now and then, and on the test, you can't go look it up, and no, I won't tell you. 5,280. Raise your hand if you actually knew that before I said it. All right, 5,280. 5,280 feet in a mile. That's the last missing piece of the puzzle. Feet cancel feet. Now I got what units left? Miles per minute. Is that what I wanted? No, I got to do one more thing. What's a factoid that I know? 60 min, 1 hour. Okay, 1 hour cancels. Wait a minute, I did it wrong. I canceled the minutes. That's right, that's it. This is hour. Minutes cancel with minutes. Final answer. I don't know. You've got to multiply a whole bunch of numbers together and then divide by a 12 times a 5,280. I don't need everybody to grab a calculator for this. This stuff won't take that much time. Has anybody actually typed it in? Yes, what'd you get? I think it's off by a decimal place. I think it's 50 miles an hour. Can you see any place that you could have possibly forgot to type in a 0, like at times by 6 instead of times by 60 on the top row? That's my theory. You got 5 miles an hour? Okay, all right. I'll take your word for it. That is true. Yeah, you're right. Okay, all right. 5 mph. I was just certain it was going to be more like 25 or 30 miles an hour, but I'll take your word for it. Okay, guys, please argue later. We have only a few minutes left till I get you in the homework. Okay, so your next topic is last time. Do you remember that last time we found things like this? How long is that curvy thing? What's that called again? An arc. So imagine for a moment that the school district decided to do a throwback. They used to do this in colleges and some high schools for a long time. They do a great big bonfire, like before a football game, just as like a fun activity. I hate to say it, but I think it probably went away mostly because of lawsuits. Yeah, some kid probably got terribly burned. So anyway, I'm not saying that they shouldn't factor that stuff in. I get that there's a danger of that. But they're really fun. How many of you have been to a big bonfire before? Okay, and it can be fun, especially like in the fall. It's a cold night. You have the big bonfire, and then you have a football game or whatever. Well, let's say the principal decided to do a little throwback Thursday on that football game, and he decides to go big, and the bonfire is going to be 30 feet across. Okay, they do that sometimes. They put like pallets out together, and then they light this huge fire. The like flames go like 20, 30 feet in the air. It's pretty cool. So here's the question. Let's say to like give people a place to hang out. He says, hey, freshmen, you guys hang out in this little wedge here, and this is going to be 60 degrees. And he says, you guys get to hang out along there. Well, some smart math kid says, hey, that's only how many feet? You should be able to figure it out. There is a formula that I gave you, and you have to remember how to change degrees into radians, and then you can tell the answer. Pause for a second so you can be the smart student who tells the principal, well, that's only 7.6 feet or whatever. I'm going to pause for a second. Let me give that a try. Okay, so hopefully you realized S equals theta R. Raise your hand if you knew that. Okay, if you didn't know that, you need to know that. This one is, again, a formula where we don't give you a testing sheet. Okay, so S equals theta R. SOAR formula is the way I say it. Then you need to know that this is not 30. The theta is this angle. It's not 60 either. It's in radians. What's that in radians? Pi over 3. Raise your hand if you knew it was pi over 3. Awesome. Some of you have memorized it. Others of you are still in the mode where you got to go like this, which is okay, but it's like having training wheels on your bike. It's kind of slow and clunky. And you can do that. So it's pi over 3, or 2 pi over 6 is the same thing. And then the radius is 30. And look at that. It worked out really nice, because if you can factor it, you should. 3 times 10. Then the 3's cancel. 10 pi. Uh-oh. Obviously did something wrong. Oh, that's the diameter. There we go. It didn't work out quite that nice, but it'll still work out pretty nice. This radius wasn't 30. You're right. It's 15. And then the 15 can be written as, if you can factor it, you should, 5 times 3. And then that means 3 cancels. 3, 5 pi, which is about how many feet? Yeah, I agree. It's more than 15, so maybe 16 or so feet. So let's say it's 16 feet. Is that enough room for all the freshmen to hang out in an area that's 16 feet long? The only way you could argue that is, here's a typical test question. They're not going to all stand right on the edge of the fire, right? I mean, really, you'd burn to death if you're, or they're freshmen though, so yeah. Anyway, so if you have this, I'm not saying, I'm just saying, you know, they're not that smart yet, but okay, do you get that they might stand in this little zone here? You know what I mean? They're not going to be standing in the fire. So then you've got your, well, how long was that? Well, that's actually part of a sector of a circle. Let's actually just figure out the big one first, and we'll subtract it off later. Let's say that from the edge of this 15 feet here, they also stand for another 25 feet back from the fire, making it a total from the center of the circle of 40 feet. Find the area of the sector. Hint, it's not pi r squared, but it's part of it. It's a fraction of pi r squared, and the angle was 60 degrees. I'm going to pause for a second while you give that one a try. Okay, so did you figure out that it's 60 degrees out of 360? Raise your hand if that was part of your answer. Awesome. Then pi r squared, well, the radius, well, it kind of depends, Mr. Server. Are you talking about the 15 or the 25? I was asking you to find the green area, which is all of this area first, and then we can subtract off the smaller area in a minute. So to start with, let's find the area of the big green wedge, that wedge of the pie, so to speak. So then that's 40 here. 1/6 times pi, correct, times 1600. That's the area of the big green wedge. But do you get, people cannot stand in the fire. And therefore, we have to subtract off this little area. Do you get what I'm saying? We subtract off that area, so it's this, but minus, well, what is it? I'm going to get different people. Let's wait. So it's row 2, person 4. 1, 2, 3, 4. Okay. Pi r squared, except with a modifier in front. What do you think? 1/6, which you reduced from 60 3/60ths. Good. And then what? 1/6 what? All right. So that, what are you doing now? You're doing the radius squared? Yeah. Pi times, say that again? There you go. And if we can subtract that from this, we'll know the area that they have to stand in. And once we know that, we might know if it's reasonable, if that's enough space to hold a bunch of people. Okay? All right, that's a pretty heavy-duty pre-calc level question on what you learned last time, which was areas of sectors, which is what we just did, and then lengths of arcs. All right, one last arc question. You got a dog. Your dog is chained up to the back side of the fence because he's bit several people, and so you don't let him run free anymore. And so Fido can run anywhere along this arc. And of course, usually if he's like most dogs, he like strains right to the edge of it and then like runs all the way around in a circle like that, right? So my question is, if he wants to run the farthest that he can in one little jog, that, in other words, that blue line there, if the chain is 10 feet long, how far can he run? That's an arc length question, except it has a really easy angle. You might be thinking, well, I don't know this angle. I asked for this whole side, which means you have a really big, wide open angle here. It's not just like a 60-degree angle. It's much bigger. All right, RV, tell me what formula comes into play. Excellent. And what parts do we know? All right. What's theta? Right. It's 180 in degrees, or pi. Do you get that this is opened all the way at the 180 opening? Okay, keep going. So it's 10 pi. And in this case, since you can estimate, pretty well, what do you think it's about? How many feet can your doggy run? 30. Come on, get a little more accurate. 31. There you go, 31.4, because that's 3.14. 31.4 feet is how far the dog can run before it turns around and runs back. Now, reality says that the chain is like hooked to his neck, and then unless his head goes into the wall, like he can't actually run that far. So it's probably shorten it up, and maybe your first estimate of 30 is a little better, but okay. All right. So there, you've learned everything. Now let's find the homework, and even though today was a shortened class, you still have 10 minutes left to do it. There's 7 super easy questions that are circled, just the circled ones. And then we go into the one-word problem, which is one of those stoichiometry / probably more like dimensional analysis questions. And here it is. It has today's date on it, which is February 25. And I said the first 7. So that's 1, 2, 3, 4, 5, 6, 7. So that means you don't have to do this or that, any of these. Just doing the circled ones, right? And on this kind, it's just asking about the other coterminal angles. And they just want to remind you to some are positive and some are negative. You can get to those angles different ways, right? If I were you, if I got stuck, I want to make a picture. Like, where is negative pi over 3? Well, that's the starting place for all of them. Negative 1/3 of the way to pi, which is over here, and negative means that way, is about like that. And oh yeah, that's like that. So now what's coterminal with negative pi over 3? Well, negative, put it in degrees once maybe. Negative 60. What about this way? Go all the way around that way. It's positive 300, etc. Okay? So find other things that are coterminal. And there's only one word problem, and I think it's pretty self-explanatory. And since you've all had, or not all, but many of you have had dimensional analysis, just a word to the wise, it's got a black background, so try writing in white ink. It's actually kind of cool. If you've never tried it before on your iPad, using a dark background and a light ink is kind of a fun change-up. All right, so then this is that same problem, and my hint for you is get it started right, which is this isn't rotations per minute. This one's one rotation in how long? No, look at the problem. I know you're looking at a planet and you're thinking once going around the sun once. That's a good idea, but if you look at the problem, it's about a yo-yo. 28 inches, yeah, but that's not, there you go. It's 3 seconds. There's your start, and yeah, you use the 28 inches when you figure out what run rotation is. So some kids just replace one rotation with one circumference right off the bat, and they replace this with a circumference, and that's okay. That's legal. Option B is you put one rotation down here, and then you say that cancels that, and you put it up here. Either way, it's going to end up on top. And what is one rotation? It's one circumference. Well, what's one circumference? It's pi times the diameter. Pi times whatever the diameter is. Anyway, I want to let you finish it from there. Notice that they want it in miles per hour. 5 tomato feet is going to be a thing. 5280, get it? 5,280. 5280 feet. All right, that's all I have for you for today.